In this section, we'll talk about synthetic division and other things we can use synthetic division to help us with. So here are the steps for synthetic division, but it's easier to show you than to talk through the steps. This blank should be a number, x equals some number. So let's just jump straight into example 1, and I'll show you how to set it up. I know this says 4, it shouldn't say 4, it should say 1. Okay, so the first thing is that we have to check this first piece, and this problem starts with x cubed, but it doesn't have an x squared in it, so we have to put that in there. We have to have 0x squared, and then there's an x, and then there's a number. So whatever our highest exponent is, we have to have every term with every exponent smaller than that, and it has to go in order. And we have to do that before we start. So once we have that, we have to realize that there's a 1 in front of there. We just use the numbers that are in front of each x in our problem. Okay? And then we're going to draw an upside down division box, and we're going to leave a row empty right there for numbers. Then the next thing we'll do is we'll look at this x plus 2, whatever we're dividing by, and we're going to set it equal to 0 and solve it. So we'll subtract 2 from both sides, and that tells me x is equal to negative 2. And that's what goes in front of this division box. So now let's talk about how we do it. The first thing we do is bring that first number straight down. And then we take that number times the number that's out in front. So 1 times a negative 2, and we write that in this next spot. That's negative 2. Then we add the numbers that are here, 0 plus negative 2, and we write that number outside. And then we repeat it. We take this 2 times this number out in front. So negative 2 times negative 2 is a positive 4, and I write that in the next spot. Then again, we add down, so negative 7 plus 4 is a negative 3. Then we repeat it. We take that negative 3 times that number out in front, negative 2. Negative 3 times negative 2 is positive 6, so we write that in that next spot. And then we add those together, and we get 0 here. So now let's talk about what we end up with now that we're out of spots, okay? This last number right here is a remainder. Okay? And that's going to be important in different situations. We'll see that in the next few examples. This right here is our actual answer. So if we started with an x cubed here, then this answer has to start with 1 exponent smaller. It has to, if this is an x to the third up here, we have to start with an x squared down here. So we'd have 1x squared minus 2x minus 3. So again, this was a degree 3, which means that our answer has to be a degree 2. And that's because we divided one of the x's out of it. So our final answer here is just x squared minus 2x minus 3. And that's because there's no remainder. We'll talk about how we would write that if there is a remainder in a minute. Okay, so the remainder theorem, this is another way we can use synthetic division. If the remainder theorem says that if we divide by something, then the remainder is f of c. So the idea here, really what this is saying, is if we divide by x equals some number, right? And we get a remainder down here, we call this, instead of some number, we call this c here. Then this remainder we'll just call r for a minute. Okay? What this remainder theorem is trying to say is f of c would be equal to r. Okay? that remainder is what f of c is equal to. So let's look at that in this next example. So this wants us to use the remainder theorem to find this answer. Okay, this right here is telling us that x is equal to -4. Okay, remember that that's f of x, right? So this x is telling us that x is equal to -4 because there's a -4 inside of there. So that's going to be important because that's what we're going to divide by on the outside of our division box. Now if we look at this, this has x to the third, x to the second, x, and then no x. So those x's are all already there, so we don't have to do anything with it. We're just going to write the numbers in front inside our division box. So here's another chance to practice. Remember that the first step is to just bring that number straight down. We don't do anything with it. We just bring it straight down outside the box. And then we multiply that number times the number in front, and we write it in the next spot. So 3 times -4 is -12. Then inside we add, so -4 plus -12 is -16. And then we multiply by the number in front. So -16 times -4 is +64. And then we add that, so we add a -5, and now I'm at 59. So I take that and I multiply it by the number out in front. So 59 times -4, and I write that in that spot. Next spot is -236. I add those together, so I add 3, and I get -233. So this last number is our remainder. Okay, so let's talk about a couple things here. First of all, this problem says find f of -4. And this -233 is that answer. F of -4 is equal to -233. This name, the remainder theorem, should tell you that you're looking for the remainder. Okay, that's the hint. So our answer is -233, the remainder. What this is really telling us is that if we found f of -4 by sticking in -4 into this problem, like we've done in the last chapter, we would get -233. The remainder is the same as this answer. The other thing I want to talk about, let me erase this for a second. I want to use this example to talk about how we would write that answer when there is a remainder. So remember that if it wanted us just to divide and write the answer, this one starts with an x cubed, which means this one has to start with an x squared. So we would have 3x squared, and then we use this -16, and we'd put an x after it. And then we'd use this 59, and we'd have plus 59. And then we put plus, and we put the remainder, but the remainder has to be in a fraction, because it's not a whole number, it's part of a number. So we'd have -233 over. Now, the bottom part of that fraction would come from this right here. And if we moved this to the same side as the x, plus 4, we'd have x plus 4 equals 0. And because it equals 0, it's this x plus 4 that would go on the bottom of that fraction. In example, well, this is really example 2, but in example 1, it told us that we were dividing by x plus 2. Remember that? So in that case, when it told us that x plus 2 that we were dividing by is what would give us the denominator of the remainder for the fraction. So if it wanted us to write out the whole thing, this would be the answer. It's still this piece, starts 1 degree smaller, but then it adds the remainder as a fraction. So if we were to do that on example 1, we would have to write our problem as x squared minus 2x minus 3 plus 0 over x plus 2. The x plus 2 comes from here, that's the denominator. The remainder 0 is the numerator. But because it's a 0, we don't normally write it, we just write that. Okay, the factor theorem. The factor theorem says that if you can divide by something and there is no remainder, then that thing that you divided by is a factor. And we're going to need this in the next section. So if the remainder is 0, then we know that we have an answer. So let's look at this. This is another way of kind of flipping that around. Here it tells us that -1 is a 0. And that -1 means x equals -1. So we're going to start by dividing by that. And because it tells us it's a 0, that's telling us that the remainder should be 0. Okay, and maybe I should erase that question mark because it's not really a question. It should be. If we don't get 0 and it tells us it's a 0, then we've made a mistake. Okay, so now let's set this up. We have x cubed, x squared, x, and then nothing. So we have all of our pieces there. We'll use the numbers in front. Remember, we start by just bringing the first one straight down. And then we multiply by what's out in front. So -1 times 15 is -15. We add these together and we get -1. Multiply that by what's out in front. -1 times -1 is a +1. Add down gives us -2. Multiply that by what's out in front. -2 times -1 is a +2. Add those together and we do indeed get 0. So that leaves us with a new equation. Remember that this now tells us that we have 15 and we'd start with x squared minus 1x minus 2. We want to solve this. Remember that this x cubed means that there's 3 answers. This 0 tells us that x equals -1 is one of those 3 answers. And there's still 2 more to find. But because this is an x squared equation now, we can use the quadratic formula. So we know that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And this is a, this is b, and this is c. Because I'm running out of room, let me just replace the information from here. So b in both those spots would be -1. A here and here would be 15. And c here would be -2. So we'll simplify that. We get x is equal to, and we'll do this first. A -1 is 1, plus or minus the square root. Then we'll do this next. You can type that into your calculator just like you see it. And that gives us 121. And then we do this next. 2 times 15 will be 30. So now we take the square root of 121, and that's 11. So we'd have 1 plus 11 over 30 and 1 minus 11 over 30. 1 plus 11 is 12 over 30, and that reduces to 2 over 5. So that's the second answer. 1 minus 11 over 30 is negative 10 over 30, which is, sorry, I'm running, it's harder and harder to read, is negative 1/3. So there's our three answers.